Okay, I'm actually bringing out a proper camera for this because this is actually going to be pretty difficult to do with just a shitty Telegram camera app. So we've got the tube set up here in triode mode. I just strapped the screen grid to the plate. You can see there. They happen to be exactly next to each other on the PCB here. This is our plate supply. It is 24 volts. This is our heater supply, so that's just 6.3 at the moment. And this is our grid voltage supply, in reference to the cathode, of course. And this is going to the grid. And right now we have 2 milliamps of leakage flowing through the tube, which is perfectly acceptable. Let's start increase our voltage here. You can see what's happening to the current. Now we're up to 3 volts on our control grid. You can see we have 7 milliamps flowing through the tube now. And this tube is weak. This is the weak one. This is a strong one, and this is the completely dead one. But I decided to start with this one. And now if I want to feed a negative voltage in here, all I need to do is swap these around. And now we're feeding a negative voltage, and you can see negative 3 volts turns the tube completely off, which is exactly what you would expect. I'm gonna turn the tube back on by doing that. So that is clearly working. Let's turn it down. And we're gonna swap the tube over to this strong tube, and we're gonna see how it reacts. So I'm gonna do that here. So I'm gonna pull this one out to see if it burns me. No, it doesn't. Just put a strong tube in here. Okay, we'll let it heat up. So it's heating up right now. There we go. We're gonna start to get conduction here pretty soon. It takes a while for it to warm up. There we go. We're starting to get a bit of current flow at this stage here. And this is just leakage current flow. Power tubes will always conduct a tiny amount even when you're trying to turn them off. In this case we had the grid at 0, so the electrons, some electrons are going to flow. So let's turn up the grid voltage. You can see we have a lot more current flow on this one. Let's go up to 3 volts. And we have 24 milliamps flowing through the tube. I'm gonna turn up the current limit a bit on this power supply just to make sure we don't have issue with that. But yeah, 3 volts, we have 24 milliamps flowing through this tube. And if I increase it further, oh wow, you can actually get a lot of current flow through a tube. 12 volts on the grid, and we have 50 milliamps. That's pretty damn good at 24 volts. But yeah, we're gonna run this only at 3 volts. We have 25 milliamps. And yeah, it's pretty damn cool. This is actually working, but this is basically just shorting out the power supply through the tube. The tube's internal resistance is high enough that it's not going to cause a problem. That's why I'm not using a cathode resistor here, because I'm just not concerned at only 24 volts. Yeah, it's actually working. And let's try and reverse the polarity of these and see what happens. You can see it just completely cuts off. So this is a great way to test tubes. 3 volts on the control grid, and it conducts 25 milliamps, which means this tube is known good. It's used, but it's known good. What I could do is go and grab a brand new one and we'll compare it. But I'm gonna swap tubes again to the super weak Mullard one, and I'm gonna keep all the settings the same. Okay, it's heating up. So this is the Mullard, which is been red plated absolute death. Heater's coming up nicely on it. This is set to 6.4, but down here we actually have 6.3 because we have some voltage drop in these cables, obviously. And I'm gonna wait a little bit more before we judge it, but I don't think this is gonna conduct whatsoever. You can see here that, yeah, it's just dead. It's deader than dead, this tube. It's not, oh, there we go. 0.02 milliamps, kind of. So this tube is just extraordinarily dead. Let's crank up the heater voltage a bit and see what happens. 8 volts. Wow, that's bright in there. Let's see if it helps any. Let's go higher. 8.4 volts. It doesn't help at all. This tube is most likely completely dead. Yeah, the only heat is from the heater, which I'm now overdriving. Yeah, 8.5 volts, and it's cooking the filament. I don't think this tube is going to ever come back to life. It's just dead. But yeah, this is pretty damn cool. This is actually a working tube tester at this stage. And what all I really need in order to make this a actual genuine tube tester is to find a milliamp meter that can go up to maybe 30 milliamps, because we have 25 milliamps here. A 24 volt industrial power supply, which I do have one, and that is going to be used for powering this. And I'm gonna need a 3 volt power supply. You can use a regulator for that, and of course 6.3 volt filament supply. And with that simple means, you can actually measure vacuum tubes and see how good they are. I'm gonna swap back to the strong tube here. Yeah, the heater is the only thing heating this thing up. Okay, we're back to the strong tube, and we're now gonna see it's warming up. I'm gonna now watch the plate current here, and as you can see, this thing is coming right up. So yeah, this is all a tube tester is. It tests at a controlled voltage and a controlled grid voltage, and that's it. The tube is just connected in triode mode. Yeah, this is actually a working tube tester. You can see the milliamps coming up to around 25. Yeah, I am tempted to go and grab a brand new Sovtech, one that has never been out of the box before, and we're gonna see how that compares. Because this is seriously quite cool. And the only thing that reversing the polarity is good for is checking cutoff. And cutoff is not a problem for any of these tubes. As you can see here, 25 volts, milliamps I mean, flowing through this tube with 3 volts on the grid. And I'm not going to touch that, we're just going to let that sit. It's pretty damn good, I have to say. I am absolutely impressed. This is working extremely well, way better than I would have ever expected. What I'm gonna do now is I'm gonna go inside and I'm gonna grab a Sovtech EL84, brand new one, and we're just gonna test that in here and see how it does. I'm gonna pull this tube out. This is a brand new Sovtech EL84. It has less than 10 hours of use on it, so let's pop it in. I haven't changed anything, so let's pop it in. It's heating up. See, can we see it? Yeah, there we go. It's coming up. And as you can see, we already have conductance here. And let's see what this brand new Sovtech tube comes up to. 16 milliamps, 17. Yeah, it's gonna take a while for it to come up. Now these tubes are much beefier than these, I think. These are the 7189 or something like that. Can't really remember the number. But this is a brand new Sovtech out of a matched quadret set I'm using for this. So you can see the current is about 20 milliamps. It's still climbing though, but it's about 20 milliamps ish, 21. And so that's what brand new Sovtech tubes give us here. And what I'm gonna do is I'm going to get a piece of paper and we're gonna write all this data down, because this video is gonna be confusing to watch. So we'll do Sovtech new Sovtech. Well, I forgot the M, whatever. It's still going up though, so it's a bit slow to be honest. But that could be because the Sovtech tubes are a little bit different from... Yeah, it's still going up, and running it at only 24 volts, I'm not expecting that much out of it. But we'll let that stabilize and we'll write down the value here and we'll see what we get. And we can test cutoff on it later, but I'm pretty damn sure it's going to be about the same. 24 milliamps. It's still climbing though. It's probably because of our low anode voltage, just only 24 volts. We're not really gonna get a whole lot of activity out of this. I think it's gonna settle at around 25. That's what this 7190 whatever settled at, which is basically a beefed up 6PQ5. Can handle 400 something plate volts instead of whatever. This is still going up. This might take a while. But it's starting to slow down. So yeah, we'll have to wait and see what it settles at. The other tubes were quite quick with settling. This Sovtech tube is much slower for some reason. Yeah, I'll pause the video and I'll be back. Alright, I think it's about to settle at roughly 28 milliamps. It's still going up slowly, but 27 milliamps, I don't think I'm going to give it much more time, because it's gonna take all day to do this otherwise. So we'll write 27 milliamps. Now we'll try this tube, which is Magnavox, which is old but still good. I'll go ahead and swap. Okay, I have swapped to the Magnavox, which is... Hang on, it's actually a 6PQ5. Yeah, that one's a 6PQ5, but these are 7191 or whatever. Let's see. You can see now the current is going up here. And I have to say, this Sovtech tube got quite hot from this actually. It's burning me. It's actually really, really hot. You can see the current on this one is 25-ish milliamps. So this tube is obviously a bit more used, which is not surprising. Yeah, you can see it's already settling at around 25 milliamps. It's going up a little bit. I'll give it a bit more time, but I'm only gonna write the rounded numbers, otherwise it's gonna become hard to read this. Yeah, let's say 25. Let's try another tube now. I'm gonna avoid pausing the camera because I suspect I'm going to forget to turn the video on. I'm swapping to the Sylvania right now. Let's see what happens. This is a weak tube. I know that for a fact. That this is a weak vacuum bulb. So let's see what happens. It's now starting to conduct here slowly. This one is not gonna have a whole lot. Sylvania weak. So what kind of milliamps it comes up with. This one's gonna take a while to rise only because it's weak. As you can see, it's just up to 6 milliamps right now, which is not much. Yeah, it's probably gonna settle at around 6.5, maybe 7. Yeah, it's slowing down, so I'm gonna say 6 point what? Yeah, let's say 6.5 milliamps. So that tube is very weak, obviously. Now we'll try this smaller, which has been red plated to absolute death. So let's take this one out, try the molded. It's heating up. You'll be able to see what kind of results we get with this, which I already know is going to be nothing, so but yeah, we'll give it a shot anyways. Molded. Dead. We'll write that down once it's warmed up enough to do whatever microamps it can conduct. I don't think it's going to conduct anything. It's just... it is dead. 0.01 milliamps. Yep. So yeah, there we go. This is obviously working. This is obviously a working way to test vacuum tubes. Savtech 27 Magnavox, old, slightly used, 25 milliamps. Sylvania weak, 6.5 milliamps. And Molded dead, 0.01 milliamps. I'm gonna increase the heater voltage on this to something absurd, maybe 8.6 volts. We'll cook it, see what happens. I'm interested in if cooking can actually revive vacuum tubes. I doubt it, but it would be fun to revive these because they could be usable tubes, you know. This one here could probably be revived because it does have conductance. It's not even, it's doing nothing. That's how insanely dead they are. It's ridiculous. The heater is putting out most of the heat in this tube. It's insane. Give it more. We're up to 9 volts. And that heater is bright. The cathode is glowing very, very red in there. This thing is running. The heater is like going crazy. Look at that. That's brutal. That's just the heater making the cathode glow red. That's brutal. Absolutely brutal. But yeah, I'm gonna cook some of these tubes and see if they actually improve anything. What we can do is we can turn off the plate supply and that while we do that, and it can just sit and cook. Damn. That's pretty damn brutal. That tube is getting hot, and that's just from the bloody heater. Look at this. It's insane. That's just from the freaking heater. But yeah, the results are that this obviously works, because we obviously get readings from this, and we use plus 3 volts on the control grid to do this, controlled 3 volts, and yeah, it's giving us very conclusive results. Sovtech, which is brand new tube, is obviously giving us the best result. This used tube, which is old, has been used. I've actually put a lot of hours on it. It's measuring 25 milliamps, so it's still good. There's nothing wrong with it. And then we have this Sylvania, which is weak, has been red plated. 6.5 milliamps, so that one's obviously weak. And then we have this Molded, which is not even enough to show anything on the meter. So yeah, it's quite interesting. Quite interesting results, if I may say so. Because I really wasn't expecting this. I don't think there's any hope for this Molded, because it is just milliamps DC. Because it's just a dead tube. Yeah, it's not conducting anything. It is entirely dead. So I'm not even gonna waste my time on it. Instead, we'll pop the Sylvania back in. That one might actually have a chance. Bloody hell, this thing is hot right now. Okay, Sylvania. Let's pop the Sylvania in. Sylvania backplate tube. They made actually quite a few of those backplate tubes. Let's see if we can get a bit of heater power to it. 6.5 volts. I'm probably gonna cook this one though, because this one does still have a tiny bit of conductance, even if it's weak. So this one might actually be worth trying to save. Yeah, see? It's coming up there now. I'm gonna cook the filament and see what sort of numbers we get. 6.5 is what we get before, so let's just start cooking the filament a little bit on this tube. Hey, look, doing that makes it conduct more. 8 volts. Yeah, look, it's waking up. It is waking up. Let's take the voltage up even more. Maybe 8.5 volts. Hey, look, it's actually coming to life now, running the heater at this extreme level of power. But yeah, I'm gonna cook it for a while. 8.5 volts is a pretty good point, I think, to be for actually cooking vacuum tubes. And you're supposed to do it with the plate voltage off, but I'll turn it off later. I'm just interested to see this go up, because it is going up slowly. And if we can get this tube good again, well, I'm not expecting it to become good, but if I could rejuvenate it, that would be cool. I'm just interested to see if it's even possible. This molded one is too far gone, I think. I just don't think there's any hope for it. Like, the gather is not even looking like a gather anymore. This is what a gather is supposed to look like versus what's left of the gather in this one. It doesn't even look like a gather. It looks more like burned trash than anything. So yeah, I'll cook the Sylvania though, see if we can revive it, because it could be used together with this one, this Magnavox tube. The plates don't exactly look the same, but they're about the same size. And you know, this is just an experiment, time waster. It is going up actually, so that's quite interesting. I'm gonna increase the voltage even further. Now we're up to 8.8 volts. Now you can see it's really starting to come back around here. I am tempted just to leave this running for a while like this, see what happens. More voltage. 9 volts on the filaments. Yeah, that's pretty damn good. I don't think I'm gonna go higher because 9 volts, we are close to killing this right now. We're almost at double its rated power. So that filament is not gonna last very long running like this. But it does allow us to do this. And now at 9 volts on the filament, this tube is almost as good as the Magnavox. But yeah, I'm not gonna touch the controls on any of this. It's interesting. I'm gonna try and do a cutoff test on it, see how it handles that. So we'll turn it off. Boom. It does great cutoff at 9 volts on the filaments, mind you. 24 milliamps. I noticed it was higher before I connected this here. So right now it's pretty low. And if I connect it, it's 24 and then it drops. So yeah, I think I'm just gonna let it sit. I'm gonna turn off the plate supply as well. We'll just let it sit there and cook. Not that I'm expecting it to come back, but bloody hell, that's that's pretty brutal. These are supposed to pull no more than 760 milliamps on the heater. It's drawing 920 milliamps. So this heater is just, it's being very brutally tortured right now. let's look at that in the dark. I have to see that in the dark. Holy crap! It's like a freaking light bulb. Look at it. Wow, okay, the camera doesn't do a very good job. I'll adjust the exposure time a bit here. Or actually I will do the ISO, I think it is. Yeah, there we go. Wow. This is like a freaking light bulb. That's ridiculous. That is how much that heater is running hard. It's literally lighting up a small portion of the bench. Look at the power supply there behind there. That's insanity. This is brutal. Yeah, I'll turn the exposure timer down a little bit because it's going to cause a bunch of lag. Yeah, that's pretty brutal. What can I say?